Hello, everybody. I'm Robby Toole. I'm the Chief Revenue Officer of QuantumBasel, and I'm excited to bring to you an industry project spotlight. And first, I want to say special thank you to the D-Wave team for giving us this opportunity to present QuantumBasel and our customers. Big shout out to Susan, Pam, Michelle, Michael, all the people behind the Qubits conference. It's going awesome. So congratulations, guys. And you're almost done. So yeah, relax a bit. Yeah. So today, what we'll be doing for our session is having 3 separate presentations followed by some Q&A. So I'll be your moderator for the session. I'll try to do my best impression of Murray, like a short and stocky version of Murray. And then I'll bring up our CEO, Damir, to give you a presentation on QuantumBasel, which is a quantum computing and AI center of competence based in Switzerland. And then you'll hear a bit from the work our customer Pfizer is doing from Vassilios, and then finally you'll hear from Edoardo from Leithà and their work with us. And excited to bring you guys examples of real-world applications of quantum computing, which is what D-Wave asked us to bring here today. So let's get started. I would love to introduce to you all the CEO of QuantumBasel, my boss, so please, big round of applause, Damir.
Thank you, Robby. So, a warm welcome from my side as well. Yes, first of all, thank you for making it still to be here. That's great. I promise I will fly through my slides so that you won't miss your flight as well. So, after having heard about 1.5 days all about quantum and AI as well, I must say it's not about technology. It's not about quantum, because what we are here facing is that we've got all this in our hands. We've got AI, we've got robotics, we've got multiomics, energy saving, quantum computing. And what it is all about, that these 5 innovations are converging and accelerating. And for those who do not know, so multiomics, this is a holistic approach in biology and integrating data for all these omic fields like genomics, proteinomics, etc. And so we are in the midst of the conversion of this. This is Uptown Basel. This is the campus. We founded the company QuantumBasel, Uptown Basel. And when you say we, you see, it's not just QuantumBasel as part of this campus, it's also D-Wave. So D-Wave has got its offices there in Switzerland, in Basel. So in the back there, the Roche Tower, Basel, France, and Germany in the back. We are this International Center of Excellence for Industry 5.0. This is campus, and QuantumBasel is democratizing the power of quantum computing. So this is our mission. We are completely privately invested. And just one slide on QuantumBasel. What we do, we provide projects. So we are elaborating together with customers what are these kind of business problems they have, and then we try to adapt those business problems with the right technology to mix it so that we can then conduct projects, as we will talk afterwards about. And so we are looking for tailor-made solutions, we are providing training, and at the end also access. And important part of the access is also GPUs. So we have there, I don't call it a myriad, perhaps for Switzerland it's quite big. We've got 500 GPUs from NVIDIA, and there will be the B200 will be delivered this year as well. So this is what we do. And I talked about convergence, and we heard this over the last 1.5 days already quite a lot. So it's the convergence between AI and quantum, where we see a QuantumBasel is now the biggest thing to go for. And what I mean with that, when you look at AI, so one of the points which are very important is this robustness. Robustness is the expression when you look between the trained data and then the data which is here while using the AI. And if these data diverge, then AI comes to its limitation. And so how can we improve this robustness by perhaps using more like brain-like learning by experience instead of learning by training data? And the second one is where we see the convergence between quantum and AI. If you look at data patterns and then you use quantum computer, then we are faced that it's like looking through the glasses at data patterns you recognize more, you see better. And I will show you 2 examples on that as well. And at the end, it's about energy consumption. I will tell you why. So, starting with the robustness. So the classical limitation, as I just said, when the data differ from training data, from the actual data, then there is the so-called lack of robustness. And we conducted a few projects also in the field of pharma where hybrid solution can increase the robustness rates for these models. And this has a huge impact on the performance on every AI application. And this is just one confidence level, the 60% out of one project we've reached. And in the middle, then you see this with the glasses, these data patterns. So this is a study, this is an academic report, and if you look at it's about fraud detection. And so on the y-axis, there is the quantum probability for fraud, and on the x-axis, there is the AI probability for fraud. And if both would see the same pattern, then, in fact, it would look like that all the dots would be on this one line. But as you can see, the blue ones are the real transaction and the red ones are the fraudulent ones. So as one can see that there are different patterns for the quantum probability calculated and for the AI probability calculated. And I don't say that the quantum probability is the better pattern, but it differs. And if you can take the best out of both worlds then, and bring them together, then this would be the way to go. And this can be used for drug development, it can be used for business decisions, and question is how to leverage these approaches. I will show you 2 examples within a minute. And then the last one is this energy consumption. Yes, it is frightening. And I've got 4 kids and they live ChatGPT. And I've told them every single time you are using ChatGPT, this is a Salesforce study, just recently came out. 1 task is responsible for 684 kilograms of CO2 pollution. This is the equal of 5 tanks, full tanks of gas. This is where we are heading towards with AI. And the worldwide energy consumption for data centers already doubled within the last 2.5 years. And it's going this way. So we have to do something towards this direction. So combining these kind of models, our vision is that we don't look just at this one model, but we combine all these models, and that we use the input where quantum could play a role. Let's say by improving, for instance, the feature selections. We had yesterday 2 fantastic examples how quantum computing can help with feature selection. So you see there in the top, I don't know where the pointer is, but you can see in the bottom, this is the feature selection. This is where quantum computing can be used. And now it's not only the quantum algorithm providing the new way of data for computing, but there are also interesting classical architectures. So we are using liquid neural networks, and these are where there is a liquid time constant, and what that allows is that we can flexibly adapt when new input comes in. So this is more the brain-like approach for an AI. It's not static. And then you see also QGANs. QGANs, these are quantum generative adversarial networks, creating such as enhanced synthetic data that is representative of the original distribution. And this is capturing all the complexity of the different types for applications. And this is a little bit the architecture behind it, but what one can recognize it's the combination between quantum computing and AI where we foresee where the future is heading towards. Now, these 2 examples I've just told you with the improved business solutions. So we have at the moment 2 ongoing projects, one with in the life science industry and one with a Swiss bank. Yes, in Switzerland you have to collaborate with banks, otherwise you just have to. And the one is the use case for patent management. So what we are looking with this life science company is where did who, in what geographic location, hand in which patent. And then we visualized all these patents owned by themselves and the competitors, finding white spots to invest and developing a strategy. And the same we are doing for a bank. There we are analyzing the diverse investment strategies with the same pattern. And I tell you, the pattern, this visualization, this these knowledge graphs are so far more accurate than if you just use AI, that we see really new kind of strategic decisions to be made with that. And when you take this, the quantum advantage, this is the hybrid, which is then the real advantage. So developing these new architectures and algorithms in order to bring them to the best result of these hybrid solvers. We, as I said at the beginning, we are completely privately invested, and we are on a long-term invested. And so we are also investing in the future of workforce, because we want to be that the kids, the future workforce is also knowledgeable about this architecture, about these technologies, so in order to solve our business problems from the future. And therefore, together with the University of Basel, we co-founded an institute for quantum computing. It's the Institute for QC2, Quantum Computing, Quantum Coherence. We already have 8+ professorships, and we are targeting those talents, and we do joint research, PhD programs, postdoc programs. We think we have to invest into this. And there you see Kai Ventures as well. This is the accelerator, the startup accelerator we have on site as well. They are accelerating startups. They already did nearly 20 investments into quantum startups over the last 2 years, and they just announced the expansion. After Basel, they already are in Calgary, and yesterday they announced a new presence in Tokyo as well. So with D-Wave together, on the one side, we are looking to understand the business problem, the quantum project delivery, the AI and data science team, and the D-Wave, they come with their professional services, with their growth team, the Leap and hardware access, and together then we tackle exactly those kind of problems for our customers. We also conduct joint events, and we are looking forward for a go-to-market strategy now that D-Wave established its presence on our campus as well. So I will skip this slide. This is just an example of projects we've delivered over the last 2 years. Why will I skip it? Because 2 of those companies are here on stage, and I think slides are not the same as if you see real customers talking about what they did. This is my last slide, the summary of everything. So what we are this hub for quantum computing and AI. We have a whole ecosystem here. We've got many people visiting ourselves. We've got the secure operating center on site. And I can just say, whenever you're in Europe, near Switzerland, please come around, be our guest, and you will see what is going on there. And with having that said, I will hand over back to Robby.
Great, thank you so much, Damir. Okay. So, thank you, Damir, for giving everybody an overview of QuantumBasel. And as Damir mentioned, we do have this great partnership with D-Wave. And so we've run several customer projects with them where we brought the customer and our expertise combined with their professional services and access to Leap. And we'd like to present 2 of those projects to you today. And the first one comes from Pfizer. So I'd like to introduce you to Vassilios, who's the head of scientific computing and HPC. Vassilios, come on.
All right, good afternoon, everyone. First of all, thank you to the D-Wave team and QuantumBasel for inviting me. I'm happy to be here to talk about some of the things we're working on as it relates to quantum and one of our use cases around job shop scheduling. But before I jump into that, a little bit of history of how Pfizer is leveraging HPC. So my team manages Pfizer's HPC environment, scientific computing. So I have the privilege of leading a team of engineers and scientists responsible for managing Pfizer's supercomputing environment. And there's a long history of supercomputing at Pfizer, right? It started in the late 90s, right around the time when the Human Genome Project was kicking off, right? We needed large-scale compute, in the rush to find new genes that were being sequenced off of the human genome. So at that time, we're deploying these large monolithic type systems, right? At that time, think about, there were many different modalities of CPUs at that time, right? We had Cray systems, SGI systems, True 64, Sun Spark systems, right? Many different modalities that, cost a lot of money at that time. There were multi-million-dollar machines at that time to look at how do we start analyzing a lot of the biological data that was coming out of there. Then in early 2000s, we kind of coalesced around x86-based systems, right? Commoditizing a lot of the infrastructure, which really allowed us to scale up the amount of compute at much lower costs, right? And allowed us to look at different use cases that weren't possible just a few years back, right? In terms of computational chemistry and drug discovery. And the cloud players did the same thing. They started building out their infrastructures, right? Based on x86-based systems, which allowed us to really further democratize access to large-scale compute and gain access to even more use cases. And for us, one of the big inflection points in terms of why we need so much compute power to advance drug discovery came around the COVID-19 pandemic. It really became clear at that time that you really need large-scale compute to accelerate drug discovery and get drugs to the market faster. So at that time, we leveraged our largest supercomputing center at that time to look at virtual screening of 500 million compounds, right? A calculation that was not possible before the advent of some of these large-scale systems. We did that calculation in 3 days, and the results of that ended up helping us accelerate discovery for Paxlovid. It also helped us with vaccine optimization, allowed us to create 3D structural mappings in a very fast turnaround time for the FDA. All of these were required for FDA filings. Really, supercomputing allowed us to kind of really accelerate that, and it really became evident without this sort of technology, you are at a disadvantage in terms of the speed, the light speed that you needed to kind of get drugs to market fast. And then we enter kind of the AI era, right? The ChatGPT moment, which really exposed AI to the general population, right? Large language models became more prevalent, and GPUs really kind of rule right now in terms of large-scale compute in the traditional sense. But we are starting to project bottlenecks in this space, right? We are looking at things like the amount of transistors that can go on these chips, right? Silicon can only get so thin. The amount of power, as you're adding more transistors, you are going to start to see bottlenecks. We'll probably have a few more generations of GPUs to the point where we have to look at new paradigms. And that's why we're looking at quantum. We see quantum as really playing a key role in the next iteration of supercomputing. And we see it fitting into kind of our overall HPC strategy. So a few years ago, maybe 4 years ago, we started building out a quantum team that's embedded within our scientific computing team and looking at different use cases. And we are looking at several use cases right now. The one we're going to highlight today is around this job shop scheduling use case, right? If folks familiar with manufacturing, scheduling is very computationally challenging. So we put a team together to look at how do we address things like complex planning of production cycles, right? How do we deal with supply chain issues, right? Vendors not getting certain supplies to us in a matter of time, machine failures, or access to talent that can run those machines on a given day, different priorities the company may have, right? All of these are very fluid. And then also add biological constraints, right? A lot of the materials we work with may have expiration dates or certain temperatures that they need to be in. And regulations, all of these kind of have to get factored in to kind of build out a schedule that's optimal. So we started looking at a variety of different tools, right? So we have a benchmark tool that we use to benchmark all of our changes to our environment. So we compared our classical approach, right? So we took what was a CPU-based algorithm. Can we optimize it kind of the current state-of-the-art classical approach? So we used GPUs to optimize as much as we could our existing benchmark, right? So with GPUs, we were able to improve the make span, which is the amount of time it takes to complete a run, by 55%, right? So we went from I think it was our benchmarks around 40 days is the benchmark. We got it down to around 18 days, a 55% improvement. Then we looked at quantum, like how can we improve, can we improve even further if we applied an NL hybrid solver to the problem? And with almost every metric that we tested the NL solver, we either beat slightly or significantly beat all of the key metrics that we monitor. So make span was increased by 60%, so it shaved like another 2 days off of our benchmark. Number of late jobs went down, so we improved it by 24% on the GPU base, 32% using the NL hybrid solver. Average tardiness went from 16% when the GPU optimized, and we improved it about 28% on the NL hybrid. And actually, we have many other metrics. They all tell a similar story. The NL solver beat slightly or significantly beat the benchmark. Where I think the exciting part for us is that this was a small scale test. What our next step right now is to look at scaling this up to much larger job runs in production, as well as adding new constraints, right? Right now, we're limited with the number of constraints we can run. We're very excited about testing this with a larger number of constraints and variables to see how this solution will scale. So that's kind of our next step along our journey here using the NL solver. And if folks want to read more about some of the things that we've done in detail, we put out a press release a couple weeks ago. Folks can feel free to kind of dig into that. And we really put a strong team together to kind of look at this as a project. So folks from QuantumBasel on the team, D-Wave were on the team, as well as many different cross-functional groups at Pfizer. The Healthcare Innovation Center in Germany, materials team, our digital teams, our HPC teams, all contributed as a cross-functional team to put this together in about 3 months, which is a great effort, really strong team put together to kind of help us evaluate quantum annealing going forward. I think that's all I had for, so.
Great, thank you. Great, thank you, Vassilios. Really, it was a fantastic project to work on. Thank you to the Pfizer team for all you did to make that possible, and the D-Wave team and QuantumBasel team. It was a great collaboration, and it was great to see the comparison between classical and GPUs and quantum and the improvement we saw. And also, I fulfilled a life dream I never knew I had of wearing a Pfizer green jumpsuit and getting to tour their factory, which was pretty cool. So thank you for that. Last presentation we have for you this session is from Edoardo, who's a data science specialist from Leithà. Edoardo, why don't you come on up here?
Hello everybody. So I would like to thank D-Wave and QuantumBasel for inviting me here and giving me this opportunity to present our project, which is extremely valuable for our company. I am a data science specialist in Leithà. Leithà is an excellence center in data science and computer science of Unipol. Unipol is one of the main insurance groups in Italy, in Europe, and is the leading one in Italy in the non-life insurance business. So just to give you a few numbers about Unipol, it employs over 12,000 employees to serve almost 70 million customers in Italy through the most extensive agency network of the country. In 2024, the direct insurance premiums collected amounted to 15.6 billion, out of which 9 came from the non-life sector. The purpose of Leithà is to provide a data-driven solution to all the business units of Unipol, while also gaining and maintaining competitive advantage. And it was with this spirit that actually we started this collaboration a few months ago with QuantumBasel and D-Wave. QuantumBasel helped us to benefit from the very best quantum solution for our problems, which turned out to be the quantum annealer of D-Wave. So we had several use cases, but we decided to tackle a use case which is particularly important for the stakeholders, for the core business of our company, which is the optimization of a policy portfolio. So as you may know, the initial price of a policy, which is the base premium, is the output of a standard pricing model, which is based on several risk factors, such as the type of coverage, the insured asset, the demographics of the person. And once this price has been determined, several adjustment factors are applied to it in order to customize the final price of the policy for the policyholder. And this adjustment factor, which are basically discounts, is a composite discount factor, is based also on the risk profile of the prospect. So, for example, on the loyalty discount, additional coverages, the historical claim data, the driving history, and so on and so forth. The purpose of our collaboration was to find the optimal set of discount coefficient for a very large population of prospects, around 500,000. It is not an easy task at all because there is a constraint of consistentness of this discount across prospects. So for example, if you consider two prospects that have the same risk profile, they must have the same discount. If you consider two prospects that have the same age, the discount coefficient associated to the age should be the same. So you have a lot of interaction in your from a mathematical point of view in your problem. Also, you have a lot of variables because apart from the 500,000 prospect, you have 1,000 of these discount coefficients. Moreover, we are trying to optimize two functions. On the one hand, we would like to increase the volume of people that do convert. On the other hand, we would like also to maximize the expected margin out of this conversion process. So we are looking for the efficient frontier of our portfolio. Also, casting this problem as a Kubo is not easy at all for several reasons. For instance, the variables to be optimized are not binary, are real numbers, and also are bounded from both below and above, because, of course, a discount cannot increase the initial price, and also we cannot discount above a certain threshold. And finally, and this is probably the biggest hurdle to overcome, is that the two objective functions contain both highly nonlinear functions of the variable to be optimized. For example, the conversion probability is per se a machine learning model, which is a nonlinear function of the discount coefficients. As I have already said, the size of the problem is quite large. So this project is still ongoing, so I cannot really disclose about any ultimate result, but I can say that for the moment, the D-Wave team has chosen to tackle the problem with a Lib hybrid nonlinear model solver. They have tried successfully different approach to handle the nonlinearities, which, at least in my opinion, was a really big problem. So for example, in one case, they approximated nonlinear function with nonlinearities that were already implemented in the library. In another case, they even introduced a new nonlinear node just for us, so thank you. Finally, since the size of the problem is quite large, we are right now in the phase where they are trying to squeeze as much as possible the size of the problem, both in terms of the number of nodes and in terms of lightness of the nodes. So they are trying to make the nodes lighter in terms of memory. And it is not easy to pursue at the same time these two directions because basically you are trying to squeeze as much as you can on all the sides, but you cannot throw away essential information. But what I can say is that even though the project is still ongoing, we have recently obtained some results that I find really promising for order of magnitude, which are already the same as those of the real use case, so 10 to the 5 prospect, and I think it is a really valuable result per se. But yet, we have not finished it yet, so I'm really excited about possible outcome of this collaboration. So thank you very much.
Cool. Thank you, Edoardo. Here, you can take a seat now.
Yes.
Okay, so now we have a little bit of time for some Q&A. So I've got some questions for you. And Damir, I talk to you all the time, so I'm not going to start with you. I'm going to start with you, Vassilios. And I will because we all know kind of pharmaceuticals is one of the industries that we think will take advantage of quantum computing first. Could you explain, in your opinion, why that is? And maybe also, coming from an HPC side of things, what use cases you think pharma will benefit from the most?
Yeah, so that's a good question. So I think there's several reasons why I think pharma will be one of the first industries to kind of look at it. So one, it has to do with the problem space we're in. If you think about what Pfizer does day in, day out, we look at molecular systems, right? Trying to look for new drugs, and we work at that molecular or submolecular level. You could almost say we're a quantum company in many ways, right? We actually have, quantum chemists that sit on our teams. We have physicists. We have engineers. We have computer scientists. So the skill set that is required to really understand and build some of these quantum algorithms actually exist already in our company, right? So it's about putting those pieces together and looking at how we kind of develop and target those use cases that target the molecular and natural world, right? That is kind of the holy grail for us is, could we get a system that can model the natural world in the same way that nature works, right? And so that is kind of the big promise for us is, and what we're really excited about is the ability to start accurately modeling our physical world. The other aspect is that, research is in our DNA, right? That is what we do as a company. So we're really good at taking mitigated risks and trying to look at how do we best approach some of these emerging areas. So we understand how to look at emerging areas, how to take calculated risks, and how to build programs around that. So I think combination of those factors, I think, is why I think pharma will be one of the first industries that will benefit the most and also probably lead the way in many ways for some of these use cases.
Fantastic. We can start by scaling the production plant.
Yeah,
right?
so we have this program that's going on. We have a few other use cases looking at molecular systems. How do we model molecular systems and look at optimizing molecular properties for certain drug targets? And how do we build a platform? So one of the things that we're focused on right now from an HPC perspective is a platform approach. What we'd love to see is how do we integrate quantum similar to how we do GPUs or CPUs. We should see it as just another accelerator in the mix. And so our job is to how do we orchestrate all of the workloads that need to happen in our environment, right? Whether it needs CPU to GPU to QPU or back and forth, there needs to be an orchestration layer. And especially in the QPU world, similar to how CPUs were back in the 90s, right? We have many different modalities. Some modalities may be better suited for some use cases than others. So you're probably going to want to have a mix of different quantum platforms within the environment and make it simple for a user to submit workloads and then have the orchestrator kind of figure out what the best tool is for the particular job. So to me, I see this as an extension of HPC, right? This is kind of exactly how other technologies have evolved over the years.
Awesome, thank you. And then, so we learned a bit about Pfizer's approach to quantum. Now to you, Edoardo, could you speak about how Leithà has approached quantum computing?
Yeah, so our first approach dates back to a couple of years ago. It was a collaboration with the University of Bologna, the National Institute of Nuclear Physics, and the NHPC Center in Italy. And I have learned a lot from that first approach because, on the one hand, it has been a really fruitful collaboration because we did a really good quality research and we published several papers. But on the other hand, I think we didn't make the most out of that opportunity of creating a true dialogue between the academia and the industry. And for example, and as a result of this, for example, none of the work that we have published, even though these have potential applications, none of them has a real practical outcome so far. Mm-hmm. And so I think that this lack of this gap in the communication between the academia and the industry is a major issue right now. So for example, I'm really appreciating what you're doing at QuantumBasel, that I have seen that you're trying to build up a real ecosystem of people belonging to different worlds, trying to basically to bridge in this gap. And I think it's crucial in this moment for this new technology.
Cool, thank you, Edoardo. Maybe then passing to you, Damir, maybe you can touch upon a bit how we've approached, bridging this gap between academia and, industry.
Yeah, this is a very important point. Although we are talking about quantum is here and that we can already do these use cases, I still think this is a conference, a quantum conference, and we should be on stage, and also all you should be. This should be a topic for all these kind of business conferences, and we are not there yet. So we, as I mentioned before, saw the necessity that we have also to support universities in terms of how can quantum computing can be used, how can students use this, how can professors use this. And so we try to bridge the gap from academia to industry project, not just with this institute, but also we are applying quite a lot for grants. So grants should be a little bit the oil helping to come out of this academic part into the real world. And then there are two more ingredients within that. The second one is you want to establish an ecosystem, then you have also to establish the regulations and all the soil for startups. And so with our campus, we provide them all the necessity. We provide them with financing, we provide them with contacts, and also with academia research so that startups can grow. And then the last part, when you go into this equation, beside the startups and beside just the oil, the grant, the money, is for sure IP. There are a lot of studies, and we heard yesterday from Heather as well from other sources. At the moment, the IP war has begun. It's a race, perhaps not call it war, but the race for IP. It's nearly doubled on a yearly basis, the IP for quantum computing. Half of all the patents worldwide over the last 10 years in quantum computing came from China, and then followed by US and all the other countries. So half of all the patents came from China. And I think that we can really a little bit elaborate on that. We can ameliorate this process. So it needs a lot to help to come from this universal, from this academic perspective into industry. I've just tackled a few of those points.
Great, thanks, Damir. And then maybe to you, Vassilios, on you touched, you have a quantum computing team within your HPC environment. And we've heard a bit about, our approach and strategy with quantum. Maybe you could talk a little bit more about how your team is approaching quantum computing and what the strategy will look like in the future.
Yeah, so our strategy really is really focused on kind of this platform approach, right? So there's kind of 4 key components, I guess, for our strategy. So one is talent development, right? Can we build a team that has all the skill sets that are required to start building out this platform and help and assist with use cases and bring in domain experts to kind of address some of the specific use cases. Second, we're not going to be able to do it alone, right? I don't see us buying a quantum system anytime soon. We also want to extend our talent and through partnerships. So we're looking both partnering with industry, like QuantumBasel, but also academia and other partners that we want to bring in to extend our talent base to address more use cases that we could do on our own. Third is around IP generation, right? So you touched upon it. But I think there's a real opportunity here to start capturing a lot of IP along the way, and being able to kind of articulate that also to leadership and saying what is the value you guys are bringing. It really helps us establish our leadership in this space. It helps protect some of the intellectual property we're creating, and it really sets us apart from so it's an opportunity, I think, that a lot of folks overlook that, right? Especially if you're early on in some of these areas, there's an opportunity to capture a lot of value along the way. So that's kind of how we're approaching it. And then, again, talking about the platform, we want to make sure we give and make the tools available for our use case development, right? That's kind of the final leg of the stool is identifying the right use cases to look at, right? A lot of folks get really excited and hyped up, and so we get a lot of attention come to us and oh, can you guys do this? Can you do this? So we have to kind of take it one step at a time, right? Is it an appropriate thing to look at now, or do we put in our backlog? So we actually have a lot of use cases in our backlog that are really interesting, but we don't think they're quite ready yet for, and then there are ones that surface to the top, and those are the ones that we want to look at. So it's about building the team that can understand the use cases, bringing in the domain experts and partners, and then having the platform to execute on that strategy is the way we're kind of, and then it's nice also to have sponsorship at the top as well. So there is, even at the board level at Pfizer, they understand the emerging area of quantum, and so they are very supportive as well in our endeavor to kind of pursue this as a research effort. So I think those are kind of the key pieces from my standpoint that are required to kind of build out, really for any emerging, that's like a playbook for any emerging technology.
That's great. That's fantastic. So all the companies out there, take a page out of Pfizer's book, have support from the top, teams, building up workforce and everything. And then on the topic of use cases, Edoardo, maybe I'll point that towards you. Could you talk a bit about the use cases you see in the insurance industry around quantum computing? Which ones do you think will have the biggest impact?
Well, I think that in principle, if you're talking about quantum annealing, the main application could be any use case where you have a huge space, and you're looking a huge search space, and you're looking for a very specific solution, which can be a global optimum or a local optimum. And you can find these cases almost everywhere, like logistics or drug discovery or whatever. But talking about insurance, this kind of problem, for example, in Unipol, Unipol is the largest agency network in Italy. It are about 6,000 sub-agencies, 3,000 agencies and 6,000 sub-agencies. And through this network, Unipol sells all its products and services. So, and this network is a graph. And when you have a graph, you're very likely that if you want to optimize a function on the graph, you end up doing something of combinatorial optimization. So, for example, being able to study the agency network of Unipol over all the country and extract some topological features. For example, for studying particular structures, or if you want to identify particular behavior in some agencies. In this case, if you are able to formulate the proper business function to optimize, I think that quantum annealing could be the way to go.
Okay, fantastic. So now we have a few minutes left. Are there any questions from the audience for any of these handsome gentlemen? Any questions? They've been left speechless. Well,
last bit of energy in the room.
Yeah. Awesome. Well then, if not, maybe each of you would like to say maybe a final word, if any of you have any last comments before we wrap this up.
Well, if you go one after the other, then I want to start with a thank you, as you already said, to the whole D-Wave team, but also to our customers. It is a great endeavor, what we started with QuantumBasel a couple of years ago. Our investor is now turning 79 years old this year, and he put $500 million Swiss francs into the development of the campus. And so it's quite a responsibility. And then to bet on technologies like quantum computing, who few people never heard before, is quite something. And so with the trust of the family of the Thomas Stehelin and his wife Monique, we are able to be presenting here. And we wouldn't been able if it wasn't partners like D-Wave and customers like Pfizer and Unipol. So from my side, thank you. And hopefully we will have some of you on stage next year.
So I want to echo that as well. I want to thank the QuantumBasel team for helping us on this journey. Thanks to D-Wave as well. For me, one of the key takeaways is like this is a journey, right? I know we get hung up on quantum advantage and supremacy. You know, if I look back, I don't think we ever talked about GPU supremacy or GPU advantage, right? It was more about the use case and the value that those use cases and the business impact. I think that's what tells the story, and that's really the focus for us is looking at one step at a time. How can we advance this field, right? It's not going to. I don't think there's going to be like a ChatGPT moment where everybody's going to be rushing to quantum and overnight, right? It's going to be little successes, evolving the technology, and focused on the business value is really the key takeaway for me.
Yeah, so I also would like to thank D-Wave and QuantumBasel for inviting me here. And concerning the business value, I would like to add that I think this is the right moment to try this new technology. But in order to do it properly, I think you really do need a very specific instance of problem to solve. So this is extremely important. For example, in the collaboration I was talking before, one of the other, I wouldn't say mistake, but thing that I wouldn't repeat was the fact that we were doing research without having in mind a very specific problem to solve. We just had a vague idea of potential applications. And at the end, it didn't work out as we expected. So this is my take-home message at least from that collaboration. But
and that's what we wanted to bring here, like you said, Vassilios and Edoardo, it's bringing little stories focused on business impact, a specific case. to bring to the community here. And so thank you guys for making the trip. Really appreciate it. Thank you for listening to us, and enjoy the rest of the conference.
Thank you.